3. Okay, back to our VS Code. We need to open our folder. I think our folder is on the desktop, right? So go to open folder. Then we select the folder from the desktop, from the location where we created the folder. Con 121 practicals. Select it, and then it will be opened here. All the files we created will be opened. Okay, so far these are the files we have created. We have a constant.c, data types.c, test type.c. I think this is the one we were looking at how to typecast. Was it? Yes, this is it. So the mistake I made was I omitted this main function. And I've been saying time without number that your program without the main function will not run. It will not execute. You understand? This is where the main function starts and this is where it stops. With the curly braces here and here. You understand? So if you really want your program to run, you must make sure your main function is intact. I hope you understand. Okay. So later when I record the program and then I put it. So you can see that this is int A equals to 10, int 10, B equals to 20, int C equals to what? Okay, 2 plus 8. Actually, this is not what we coded that thing. Let me remove it. Do you understand what I did? I commented this one out. So it means compiler will jump this one. It's not going to compile this line. Line 6 is not going to be compiled. Understand? Now, then inside this VS Code, I want to introduce another thing before we move on. You see, if I'm moving like this, you see the red line here, the red dot here. This red dot is used to break it's a breaking point to break your code. If you break your code here, your code will compile from top to this place, and it will not pass down here. So normally we use this break code for debugging, during debugging, so that wherever we have issue in your code, supposing your program has more than this number of lines, this having up to 100 or 200 different lines, then the breakpoint will help you to break at a point, run the program from top to that point, and then see if there's any error. If there's no error, then you remove the breakpoint by just clicking on it to be removed. Then you take it to another place where you think there should be an error. You run it on top down. Then under it will not be wrong. So the program will indicate where the error is when you debug. So that's the issue, the reason why we use breakpoint. That's just aside from what we're doing now. All right, now so from this code we have this one, D. We're not using C, that's why I cancel it out there. D has been typecasted explicitly here. We say D equals to float B slash A. That is the value obtained when you divide B by A. And when you run this, definitely you are going to see the result. Okay. I think I was able to resolve the issue of having to run our program in this. Let me see. That actually resolved it. Wait, have you see here? So we have to. Okay, I have to remove that. No, it's correct. I hope you notice why this thing. When I said this thing was showing red here, the title was red because of this. I commented this one out. When you comment it out, you see how it's red now. That should tell you that this program is error. It's not error free. It's containing an error. So you need to debug. And this side, you also see some error lines here. Okay, these error lines you also tell you that this program is full of errors or is containing an error in it. But when we remove this and save it again, you will not see any red line here. Have you noticed it? So you have to be observant when you write it. So now if we run this program, it's going to work. Let me see. There was a place, I think this is on the terminal. It's running on the terminal. Debug anyway. Build finished successful. Toner will be reused. Press any key. Okay. So I'm able to open the output window. So let us run it the normal way we have been running it. Okay. The normal way we have been running it, we go to command prompt. That's CMD. Open the command prompt. So change directory to what? Desktop. Then to the program, the cd com space 121 underscore practicals. Successful. Then the name of our practical is test underscore type dot c. So it's going to open the IDE for us. That means we're going to run it using what? C++ IDE. So look at the program here now. F9 is for what? To compile. F9 is to compile. And F10 is for what? To run it. Is this still compiling? It's still compiling. Okay, that's compiled. 63.59 seconds. Okay. So we can now run the program. There's no error, no warning. Everything is fine. So when you press F10 now, it's going to run through the output window. So you see, what we're looking at was this value of D, which is 2.0. That has been typecasted effectively. You see that all these ones are integers. They don't have a decimal point. 10, 20, 40. They are decimals. Sorry, they are integers. While this one is float. And so that's how float is recorded. 1.1. Sorry, 2.0. So I can just press any key anyway, then close the window. So that is done. Let's go to the business of the day today. Let me still minimize this one. Close that one. Close this one. Then we have the Explorer. Let it be there. So coming to our practical manual, this is the first program we have, typecasting. We have a program here that's going to typecast. Okay, almost the same thing with what we did. So we're going to skip this one. You're going to run this one. This is explicit cast. So you're going to run this one and write the output on the screen here. So you have students task. Write a program using the static variable to count function calls. What is a static variable? We discussed that in our previous class when we talk about variable storage classes. Talk about storage classes here. We have this one, static. Preserves variable values between function calls. So go and do that. Then use get car and put car to read and display a single character. Experiment with scanf function for different data types like int, float, car. Then you write your code down there. Then you have short answers here. What does the scanf function do, and why do you use this symbol before the scan variable as variable name? What is the difference between getCar and the scanf functions? So then you'll be evaluated. So let's move to unit 5, which today's date is 30th of July 2025. That's the date we have here now. Your behavioral objectives include, by the end of this unit, students should be able to understand what control structures are. Then use if, else, nested if statements. Then you should also be able to implement loops using for, while, and do while. Then you should be able to apply switch and go to statements. And then finally, you should be able to identify and avoid infinite loops. Infinite loops. What is an infinite loop? A loop that loops without terminating, and it's not good for a programmer. All right, the key concepts include control structures. What are control structures? They determine the flow of execution in a program. They help the computer make decisions and repeat actions. So actually, that's the work of the control structures. They help in decision making. That's the reason why you see the computer sometimes behaving like it's a super machine, or it's behaving like it is a human being, can take decisions, can react to responses, or can respond to a stimuli, just like human beings can do. So we have the following data types, the types of our control structures, which are sequential, selection, iteration, and jump. These four. For sequential, execute statements one after the other from top down. That's the normal way the programs have been running. If you write this program like this, from here to this place, the computer or the compiler will start compiling from top down, following each step or following each line of code, step after or line after line. That's how it's going to run it, and that's how it's going to execute the code. And then we have selection. Selection makes decision if or if else, and then switch. That's what selection does. Select between options. Supposing you have two options with you, then you can use if else condition. For if requires only one option, that means it's going to execute when the condition is true. Once it is false, the whole of that segment is going to be exempted in your code. It's not going to touch it. It will leave it behind and move ahead. Okay. But then for switch, we will look at them anyway. Iteration. Iteration is what we mean by repeating a code. Repeating a code. We have these codes, these are statements. We have the for statement, we have the while statement, and then we have the do while statement. Each of them have their own function. We shall be looking at them one after the other. Jump. For jump, you have to transfer control from one point to another point. You jump some codes in between to another point. That's what we call the goto statement. Okay. Now we have some activities here. We shall be looking at them while we explain their functions. The first is to make use of if-else statement. How do we have an if-else statement? Now looking at this code, where the if-else statement comes in is here, where you see if score is greater than 50, then print you pass, else print you failed. These are the way we're going to implement it. But first of all, we'll look at how we can collect data or input from the user using this printf. Enter your score. The score will be entered, and that will be used, will be taken in using the scanf function. So while we are exploring the functions of or the workability of the if statement, we'll also see how the scanf function can work. Exactly. So, okay, let's go and create. Let's use our VS Code and create. Let's click here. Okay. Inside, and then create a file by name if statement. We are using if you like, let's put it if else statement stmt.c. all right, that's the function name, or that's the file name anyway. So let's start typing hash include what stdio dot h. Okay, we have our int main. Let's not forget the main function today. Int main, open and close. We have a long suggestion here, which is not going to give me what I want, so let me just leave it. I'll write my own. Okay, inside we have print. I think that's the first statement. We have printf. Or do we declare the variable first? Okay, let me go back to. Okay, we create a variable. Now, which type of variable is this? What is the storage, the variable storage of this one? What is the scope of this variable? Scope. Is an instance? Automatic variable now. Is that not so? It's auto because it's found within the word. So let's have our function first of variable int score, and nothing has been assigned to it. All right. So we want to collect scores from users. Printf, enter score, enter your score. This is correct. So when then the user enters the score, we use the scanf to accept it. Use the scanf to accept the score and assign it to the variable score. Score here, we now accept what the user enters on the screen, using the keyboard while the program is running. I hope that is understood. So we're not going to use scanf. That is selected automatically, and that's correct. Then, after the value has been, that means it has given the user the liberty to enter any value at all. All right. That is, it's not going to make use of just one value. We're going to make use of multiple values. So if score is greater than or equal to 50, then you should take decision. If score is greater or equal to 50, then what happens? Our code comes in. You should print you passed, then you close. Out of that one, use the else statement. You passed with the escape sequence /n. Okay, print if you passed. Let me accept this one. You passed. Then out of this code, you can now write s print you have failed the exam. Okay, you have failed the exam. Okay, I think that's all we have to output. You have failed. We're going to return 0. So we don't need anything more than that. Return 0 because of the int we used before the main function. This main function is of type int, so we have to return the type. So 0 is an integer. How many of you know that 0 is an integer? Since the function is not going to return any value, we use 0 now to return it, and that's all. Okay, so inside the printf function, you can put anything you wish to put, but now the benchmark is what? 50 and above. Once the user or once the score is more than 50 or is 50 and above, you want to output that yes, the person has passed the exam. But if the score is less than 50, anything less than 50, that is what the else statement captures. You understand? Was it in this class I told you that no, it was in a different class. If you have more than 2 choices, then you are going to continue to use s until you get there. All right? You understand? So once it runs, I think we are going to come to that anyway. I don't know whether it's part of this or not. Where that can be used as an additional or a bonus to what we're supposed to know. Okay. We don't have that anyway. We don't have it, but we can do that as bonus. Is that clear? We can do that as bonus when we have time. Okay. All right. So what I'm trying to tell you is that this else statement captures the second option. It means that you have 2 options here. It's either the user passes or the student passes the exam or he fails. There are 2 options there. And what it's checking is the score. So the score now checks whether the condition now checks whether the score is within the pass mark or is out of or below the pass mark. And then it outputs the result. Now, when we run this, one of these will be printed, or one of these will be displayed, either this one or this one, but not both of them. You understand? That's where we come to when we talk about our Boolean. That the Boolean give you at least one result, though we have true or false, but it can produce a true result at a time, or it can either print or produce a false result at a time, and not both of them at the same time. Okay, so what we need to do now is to go and run this. We go here, let's use our command prompt and run the program. Already we have selected, we have changed directory into the place where we have to run it, so just simply type if underscore else underscore stmt statement dot c, then press enter. It's going to open it from the dev C++ environment. Okay, it's already opened. Can you see there? It's already showing here if else statement is already opened here. So from here we can run this program. First, let's compile by pressing F9. F9 will compile the file. That's compiled without wasting time. 0 errors, 0 warning. Then F10 now runs the program for us. Okay, it requires that we should enter the score. Enter your score. So let me start by entering 25. The score is 25. Press enter, and you see the result is what you failed the exam. Although we had 2 options there, but it has run to the conclusion now because it requires only one option to. It's going to take only one option, make use of only one function. So the program is over already. So you can press any key to go out of this place. Is that clear? If you want to run it again, you run it for another student. You assume that now we are running for a different student. The student now score 85. Then the result is what? You passed the exam. Okay? And that is done. Now we are not taking care of exceptions. What if the user decides to enter any value instead of what? Instead of the intended values. Sometimes users are expected that they tend to behave the way they wish to behave. It's just to test the program to see whether it's going to function. We haven't done that. We didn't put the boundaries. But let's just try to see what. If supposing the user, instead of inputting a value, an integer value, may decide to input A, what happens? It's not telling you that you failed the exam. You understand? So when you are writing your code, take into consideration that the user, what is the user going to do? How is he going to behave when this program is finally put to use? So try to check all those ones and take care of them. That is not what we are doing now. And we don't have that time to do that. That's beyond our scope now. So let's just move on to what we are expected to do further. Okay, you will learn that further, okay? Activity 2 is going to demonstrate how loop can be utilized in a program. Loop multiplication table. Okay, let's study this program. From this main function, we have int I. I has been declared as a variable. Then we have for I equals to 1, that is the starting point. I is less or equal to 5, that's the stopping point. And then I plus plus, and this is just the incremental point. You understand? I plus plus means it's going to increment the value of I by what? By 1, just a single value. So that if I were 1 initially, by the time this loop iterates once, it's going to be 2. I will be 2. By the time I iterate for the second time, I will be 3. By the time I iterate for the third time, I will be 4. By the time I iterate for the fourth or the fifth time, then I will be what? 5. So let's okay, let me just copy this one. The rest I will just type it and copy this one. So this is for loop. So we are going to create another file and name it for underscore loop dot c. Is that okay? Okay. As usual, let's start with the hash include std. So I've been programming with C++, so I normally try to write IO string. Then I come to realize that this is not C++, but C. Okay, we have a suggestion there, int main. Anyway, normally I leave the first line. Let me leave that one, then start here, int main. This one. Then we start with what? We declare a variable int I, right? Yes. Without assigning any value to it. Then we try to use the if statement now. If I is equals to what? Is equals to 1, comma, I is less or equal to what? I is less or equal to what? 5, right? Yeah. And then I plus plus. I plus plus. Okay. So that is that. Okay. Instead of I here, I wrote minus. I is less or equal to that, and then we open another curly brace here and enter inside. Then let me paste what I copied from the print f, that's print as formatted 5 times whatever the value of I is at that point is equals to that result you get, slash, enter the next line, then I, comma, 5 asterisk I. Okay. What is this thing going to multiply by? I multiply by 5. That is the multiplication of 5. I hope we even mentioned it. Multiplication table. So everything is multiplying by 5. That's what it's going to do. So this will multiply 5. This one, okay, wait. Understand that what? This one will just appear before the result. This one will appear on the screen anyway. Okay, so whatever value that I turns to, that is starting from 1, the value will be placed here. So that will be 5 times 1 equals to the result you get when you multiply 5 by 1. So the result, the first one should carry 1, and then it moves down, and it's going to repeat this thing. Remember that this is a loop. Loops normally repeat an action. So the whole of this will be repeated for the number of times that you have placed in this block.
So
we use what? Wait. Is it 4 that we're using? Oh, sorry. Okay, we use if initially. That if is still moving with me. Okay, it's 4. Thank you for that reminder. So for I equals to 1, I is less or equal to 5, and then I plus plus. All right, that's it. That's it. Definitely, that's it. Okay, we are not finished. We will now come out of this and return. Return I. return that to 0. Save it. What is it? Another error again. I think we haven't finished. Semicolon. Okay. Look at it here. I plus plus. Okay. Wait, it's not here. This one. Semicolon. This one is also semicolon. Alright. That's comma. Okay. So we are good to go. You see this thing is without error again. The file name is there without error. So we can now go freely without any issue. Let's run it here. Now type for loop dot what dot c. It will be opened on the IDE. For loop is already opened. So F9 compiles it, and this has been done without any time wasting. F10 now runs it. Okay. Can you see what I was telling you? 5 times 1 equals to 5. 5 times 2 equals to 10. 5 times 3, 5 times 4, 5 times 5. Okay. Okay. Yes. You should note that when we have greater or equal to, it means all the boundaries or both the boundaries are inclusive. Okay. That is 5 was also included. You notice it? We say 5. Look at this middle term here. It said I is less or equal to 5. That means whether I is less than 5, it can also work. And also, if it is equal to 5, it should also perform the function. So you can have I starting from either -2 down or -2 up. But so long as it is less than 5, it can work. The only situation where it's going to stop is when I is greater than 5. Then it is going to stop. So supposing you want to do this for 12. You now say I is is less or equal to what? 12. So that you have a times table of 12. Now each time you update, or each time you change something to your code, what you do? Compile it first. That is for C program for you. Each time you update any information or change any information to your code, make sure you save it and then compile it first before you run. Otherwise, if you now run this code, it's going to produce the same result it produced in Alien, because that was what was compiled. Let me do that so that you can see. Okay, so you see, when I run, you still see the same result, 5 times 1 up to 10. But when you want to update a change, then compile it again. F9, it will compile. So once it compiles without errors, you can now run it to see. F10 will now generate a multiplication table of 5 from 1 to 12. So you know that 5 times 12 is 60. I hope it is interesting.
Yes.
Very nice. So let's move to. Yes?
So supposing that in the number of time iteration will occur, you declare a variable and collect the value from the user. Then the number of time the iteration will go is the number of time, the number of, that's the value, the number of time that will occur. That's 15, the number of time the iteration will occur.
Yes.
20, the number of time.
It's possible you can do that. It's possible you can do that. You can use, just like in the initial example, you can use the scan f function to collect the value from the user. Then from here you will now say whatever value you collect at f, you may whatever value that is collected will be assigned to I here. And then you will also create the initial point for that I. You no longer make use of this I again. You may start from 1 to the value that I is. Okay. Supposing we have, for example, you may decide to say now the value that is going to be collected is j. So let's call it int j. In j. So in j can be, let's say the value that is collected from the user is 15, like you are saying. Supposing that's the value collected from the user. So you will now say I is equals to 1. I is less or equal to j. You understand? So instead of saying it's 12, then you now say I is less or equal to j, and that will be accepted. So I plus plus. You understand? Already I has been assigned a value. So you are not going to make use of 2 variables there. You understand? So this will also run. If you like, let's do what? And also it's possible that you can also change this value. It will not be 5 fixed. There will be a different value, or the value will be collected from the user again. So whatever the user enter, it's possible. Everything is possible with your program when you are able to think very well. So you will make it in such a way that the user is going to enter 2 values. So 1 will be the multiplier, or what do you call it? will be the fixed number to be multiplied by, while another one will be the alternating number that will be alternating from 1, 2, 3, 4 to the last level.
So why are they not running it? Why are they not running it?
That's multiplication. We're doing multiplication table. We want to show the multiplication table. So for multiplication table, start. Okay, this number, code number here, 1, 2, 3, 4, 5 to 10 here. Okay, that's just a number. That's line numbers. That's for line numbers. Some programming languages, they have line numbers, especially the editors. These are code editors. They come with line numbers. Some of them come with line numbers for easy identification of statements. And that is during debugging. It helps you to know, okay, let's line number this. Supposing there's an error and it has been mentioned here, go to line number so. Then supposing there was no line number here, you will be counting, okay, 1, 2, 3, 4. You understand? So to save you from that stress, that's why you have those line numbers. But anyway, let's run this code and see. Let's first of all compile and then do what? Run. It will now multiply to 15 because j has been used as 15. So whatever you alternate the value of j to be, that's how the number of times is going to multiply. So that's that. Let's go quickly to the next challenge that we have. The next challenge, which is activity 3, we have 3 and 4. We have 2 more to work with. This one has to do with the switch statement. Okay, without wasting our time, let's quickly copy this code. Let me copy the whole of this code to the end here. I'll explain the code to you while we create a new file here. Our file now is what? I hope you see where I used to click to create a file here. When you're using your VS Code, make sure you click this open place here. If you click this open place, you see the box surrounding this. So when you click on this plus sign here, this icon here, to add a file, it will be added as a file under that folder, under the root folder. Yes. Switch statement dot c. Switch statement dot c. And then let's just paste Ctrl V. We paste everything there. So let's go through the code line after line. There is some error to this code. There are errors to this code. So let's look at them together. Let's debug together. This one is okay. Int main. Then inside the main function we have the main function starts from here and ends here. Yes. Then inside the main function we have int day has been declared here without assigning any value. Printf enter day number between 1 to 7. Okay, that is the message that will be prompted for the user to act. Then the user now enters any number between 1 and 7, and that number will now be assigned to day, which is what you declared here. Okay, they will assign to day. Switch day. We are now using the switch statement starting from here. Switch day. It opens here and closes here. All right. Case 1. Okay, this is where the error is. You separate this 1 from that case. Understand? Separate that one from case. Then separate this one from case. Then the error, at that stage, the error should be over. If the day, that's the value entered is 1, that becomes case 1, print Sunday. Alright, print Sunday. That's the first day of the week. And then you break this. Okay? This also has to enter a new line. Break. You understand? That's where another mistake is. It's supposed not to be on the same line. I hope you are following. So sometimes what you see you see here, if you copy it directly, it will give you an error. Normally a line is supposed to break, to stop with a semicolon. Once it stops with a semicolon, the rest that is in front of it is no longer part of the statement. But break is supposed to be part of the statement. So it has to come to the next line. Maybe this was done because we wanted to minimize space. That was why we have it that way. So let's go over there. The next line also have case 2, print Monday. Then you also have to break it to the next line. Okay, I think we're getting there. Then by default, print other day. Okay, print other day. And then we are over. This is here. This one ends here. So default print f other day. Okay, this one closes. Then switch. Okay, I think break. We need break again. I don't think. Then, okay, I see the problem. Return already. This is underlined, and my eyes are not seeing it. Okay, you must separate the return from that 0. All right. So that is one thing about programming. You have to debug whenever there are errors. Is that clear? Okay, so get ready. Sometimes add box to the code and ask you to debug. So you are going to copy the code correctly and debug so that there will be no errors. Okay, that is that for you. Now this, I told you that once you see your file name in white, you should know that what? It's error free. It's error free. If you attach this in there, you see how it is reddish in color number, and then there are some errors of elements of reddish color here. This is a code summary that's giving you the summary of your code. So if this thing is having something red here, it means it is error. I hope you can see from there. Okay. Now when you remove that, the error is gone, and then you see no error here. You can see this one in white. Okay, so let's go there and load it to this thing. Switch underscore stmt.c, right? Press enter, then it opens it up there. Go to dev C++. Now you can compile it. Is it done? Yes, it is done. Look at this program here. Now we have an executable code, so you can execute using F10. Enter is code. This thing does not understand what we wrote there as 127, so we need to go back and maybe encode it in a different way so that the user will understand what is inside this bracket. You understand? Okay, enter a day. If you like, you can change it to number, to string instead of numerals. Just change it to string. So the person will enter 6. If I enter 6, then it's going to give me another day. It's another day. It is programmed to output only 2 days. Can you see that? It's programmed to output only 2 days. Okay, I think the actual problem is from here. Actual problem is from here. So if you are able to do it this way and then compile again before you run it, you can see it very well now. So you can now type 2, press enter. If you tell you it's Monday, is that not so? So it's not left for you to go back to your code and change or add many cases, more than one cases. So normally you see that switch normally uses integer value, 1, 2, 3, 4, 5, 6, like that. So the default one, you should have said, or if you have exhausted all the days, supposing you have exhausted all the days, 1 to 7, then your default should be from 8, 9, 10 to tell the user that you have entered a wrong number, or you have entered a wrong input. You understand? You can either tell the user you have entered a wrong input, try again later. Is that clear? Even here you can customize this and say wrong input, try again later. Wrong input, try again later. Okay, with an exclamation mark. That tells the user that he has entered the wrong input. Then you now compile again, compile the code again and run it again, and then you see if I enter 3 or 9, let me say, starting from 3, since we have not assigned anything to 3, even 3 I tell you the same thing. Wrong input, try again later. You understand? That's what you tell. I'll put it to the user. So that's it.
This case, so I can make the case to be conditional, only the conditional statement. Because this is another different thing. Okay, like the condition.
Switch, normally that is the condition. This is the condition for the switch statement. This day here is the condition. For the value that is taken, it outputs only one value among several values, or it evaluates one option out of a number of options. If you have more than one options, and these options you want to output only one at a time, especially when you don't want to use the if statement. So it's just an opposite of the if statement, or can we say it's an if statement in an improved version. It's an improved version of if statement. So that's just what you do it. But what I told you is that normally it uses integers as its cases. So that it numbers the cases, case 1, 2, 3. You have, these are options, option 1, option 2, option 3. So the number of days in the week, you have 7 options to it. Option 1 is Monday, or Sunday, Monday, Tuesday, Wednesday, up to that. So that's what we do. All right, the final one, activity number 4 is the goto and infinity loop examples. We have just one example here that's handling that. Let me also copy this, all of this, and then I will edit. Then let's move to the, okay, what should be our file name now? That should be goto statement. Goto. Make sure your file name is not the same as it shouldn't be a keyword. Thank you, sir. .c. All right, you're welcome. Then you let's paste this and see what is there. Okay, you know that this is error prone. It has some errors. Let's edit where there are errors. Let's start from top down. This one there's no error with this first one. Then this third line, there's no error. In I equals to 1, I has been declared to be 1, or has been declared and assigned the value of 1, then start. Okay. Print, count, the number, the value that will be entered there, the value that is there, comma I plus plus, then I will be added, will be incremented there. If I is less or equal to 3, go to start. Okay. The start is here. So that is line number 5, you understand? So once you have go to start, it means you are going to move back to line number 5. Okay, return 0. I'll give a space there. So your code is error free now. We can run it there and see what is happening. Once we see what is happening, we can understand it better. Go to underscore statement dot c. Let's enter. Then go there. This is the code. Let's now compile F9. Compile it without errors. F10. Okay, it has counted between 1 to what? 3. Okay. This has achieved only one thing. It doesn't achieve the other one. It has only achieved one thing. What is it that it has achieved? It has achieved the goto statement. You understand? Okay, I forgot. I forgot to include the infinite loop into this. Okay, so that is one thing that is left out of this. So we'll look at the infinite next time. Let me just stop here for today. But the goto has been implemented. It has been implemented successfully. Let's visit this code again and go over it again. You discover that we have start here. Start. You should note that this is also a keyword, and you cannot use it for any other thing but the function for which it is. Start is placed here, so that when you we add the value of int to be 1, and then you incremented it here by 1 again. So this condition now evaluates. You see that this has nothing like the open curly brace. If you like, you can put it and then close it here. Okay, let's copy this thing, take it inside, paste it there. Now it will work perfectly. What happened is that this test whether I is less or equal to 3. Now if the person enters, okay, I'm coming to that. If the person enters any value other than 3, what happens? But we are not having any value there that is going to be higher than 3. You understand? We have constrained it to work within this value that we have here. I'm trying to round up, that's why I'm a bit faster now. I'm trying to round up. But once I come back next time, we'll look at that infinity. So let me just run it, compile it, and run it again. So you see that it still works. What I was trying to emphasize here was that even without this curly brace, your if statement can work. You understand? But it's going to iterate only one line after it. Is that clear? It's going to consider only one line that follows the if statement and nothing more than that. But for better encapsulation of your code, hiding of your code, use the curly braces. The curly braces tell you that everything within the body of this curly brace is belonging to this code segment, and it also shows that the block of code starts here and closes where the curly brace stops, and that is that. So for better understanding, that's how you do it. All right, this is where we draw the curtains for today's practicals on the topic on control structures, which is unit 5. So we have come to the end of the video. So do well to share our video, like and share the video to